好，因为下午第一节我正好要补充一下。所以这一节啊，我记得刚开始就有跟各位预告说，说不定呢，我们也可以来教一些呢，就是有关于你们将来升大学的衔接教材。那至于呢，也是让各位稍微感受一下，如果你将来遇到教授啊是用英文上课，它上起来呢会是什么样的一个味道啊？那你们如果中间有想问问题的话呢，你也可以用中文问问题，没有关系哦。因为重点还是说你有没有进入状况。啊，万一我突然问你们问题的话呢，你们也不要紧张。万一不知道我问什么，你也可以叫我翻译一下。啊，万一你没办法用英文回答，你也可以用中文回答。OK， 好，我们再补充一下啊，再看看，哎，最左边是谁啊？家人后面是谁？雅乔。好，我再等一下他来。有点想。
我们做的比闪电媲美。我们做的比跟着上做啊。
有啊，我们做的比较好吃。哎，我们这次做的好吃。
好了，我看应该不等啊。OK， 我看大家也醒的差不多了哈。OK， let's get started. Today's topic is why is kinetic energy. Okay, I say kinetic energy simply by looking at this symbol K. Kinetic energy in Chinese, what is it? 哎，厉害！哎，知道我在讲什么 ？K means kinetic energy. That is why we write down the capital letter K to denote as the kinetic energy. So my question is, why is kinetic energy 1/2 mv squared? Since a few weeks ago we have learned some calculus, and of course you can answer this question by using some uniform accelerated motion, but I want to use a more official way. That is, I want to prove that the kinetic energy is 1/2 mv squared simply by using the calculus. Okay? Okay. So take a closer look at this term. Since your k is now related to the value of the velocity, and that means if your object moves faster now, then your kinetic energy is going to be enhanced, is going to be greater. Okay, so what kind of factor would push something to move faster? That is the force. Okay, so if there are multiple forces acting on an object, it's going to accelerate and move it faster along a path. So I got force, and we get displacement, which is, I should start to talk about the kinetic energy from work. I should answer this question starting from the work. And to be more specific, I want to talk about the net work. The net, can anybody answer me what is net? N-E-T? One, okay. OK， 没错，它是一个 net。那 net 在这边呢，也可以当做是净的意思，就是净工，比方说净那个干净的净。OK， 好，所以当我写这个 work，I put a soft net， 也就是说我想要找这个净力做工，也就是合力做工。So if I want to talk about the net work, and according to the definition of work, by using the calculus, this is the integral of f dot dx. F dot dx. And what is more, I should put a stop right here. This is also the net force. Because there might not be just single force acting on your body, there might be multiple forces acting on the body. So I should write it down as F net. This is net force. And times the dx means a really small amount of displacement, really small amount of displacement. And that means I'm going to integrate the F net with respect to the position and evaluate it from some kind of initial position to final position. Is everything okay? this is the definition of the network, okay, by doing the integral of the f dot dx. But later, let's say the multiple forces acting on the body, all the forces, the sum of all the forces is now parallel with the displacement. So later, I'll just simply drop the vector form if the two quantities are parallel with each other. Okay, but currently I still cannot take this integral since the f doesn't have any x in it. It doesn't have any x in it, so I cannot take this integral. But don't worry, because according to Newton's second law, what is f? Can anybody answer me? You can raise your hand. What is Newton's second law? Sure, then please.
Mass times acceleration.
Wow, mass times acceleration.哦，我没有想到你们用英文回答我，我们没有套好招，对不对 ？Mass times acceleration, awesome. F equals mass times the acceleration. Mass times the acceleration. Okay. Since I have already expect that f is parallel with its displacement, so I just drop all the vector form, the vector symbol out. Okay. So don't forget the limits above and below the integral. But so far, I still cannot integrate this term. But at least I know that the mass is a constant, is a scalar. Vector means 向量. So can you guess what is a scalar?
存量。
存量厉害的 scalars. And 如果你这个质量是不变的话 you can also take it as a constant. If it is a constant, then you can move, you can take it out and put it right in front. Is it okay? So I'm going to keep writing it as the mass times the integral evaluated from some initial position to final position and times the a dx. But the acceleration still doesn't have any x in it, so I still cannot do this integral, I still cannot take this integral. But no problem. We still know some other form of acceleration or some other definition, equation for acceleration. So, according to your memory, what is the equation for acceleration? Does anybody want to answer this question? What is the definition of acceleration? No problem, I'll help you to answer this. Acceleration means the change in velocity over the change in time. And in Chinese, 就是速度的变化量除以时间的变化量. The change in velocity over the change in time. But anyway, today I want to do the calculus, so I need a more calculus version. So I would prefer to write the acceleration as dv by dt. Is it okay for you? dv by dt. That is the derivative of velocity with respect to time t. Now I'll call this the instantaneous acceleration, in a more calculus form for the acceleration. But you might be wondering, you say, hey Nash, you say you cannot take this integral since the f doesn't have any x in it, but now you are making things more complicated because I can see three kinds of variables like velocity, position, and time. You are making things more complicated. How am I supposed to take this integral? So I'm going to show you some trick, some magic. Okay, I'm going to use a so-called chain rule. Does anybody ever hear the chain rule? It's okay. The chain rule, let me show you. This dv by dt, I can separate it as dv on the left-hand side and dt on the right-hand side of the body. Okay, and I'm going to put another 2 dx. Since the 2 dx could be cancelled out, so that won't make any change. So I think it's fine to rewrite the dv by dt, simplify all this term. Is it okay? Okay, so I'm going to put the dx run on right hand side. Okay, so here's the magic. I am gonna cancel the 2 dx right here. So what we are left with is the dv and the dx by dt. And officially, this is called the derivative of position with respect to time. 也就是位置对时间的微分。What is it? What is dx by dt?
速度
Velocity, yes, 没错，它就是速度啦。Which means the dx by dt can be simply written as v. So, we have already simplified all this term from f to acceleration, and finally, what we are left with is the v. I got only one variable, so all this integral is going to be mass times v dv. Originally, I have 3 kinds of variables, but now I only have 1 variable. That's awesome. Originally, I want to integrate the f dot dx and evaluate it from the initial position to a final position, but I'm now taking this integral v dv. So I should replace the limit. I should replace the initial position and final position simply by initial velocity and the final velocity. Is it okay for you right now? Okay, so a few weeks ago, I have taught you some simple calculus. It's not that hard. Okay, so if I want to do this integral, take this integral of v dv, and that will simply be v squared divided by 2. Okay? V squared divided by 2. And that means if you try to take the derivative of all this term, there's v squared over 2, and that will be v. Okay, so basically integration is some kind of inverse steps of doing the derivative. So, but please don't forget the limits on the top and the bottom of the integral. So this term v squared divided by 2 is going to be evaluated from initial velocity to final velocity. So I'm ready to plug it in. I'm ready to plug in vi for v. I'm ready to plug in vf for v. Okay, so it turns out to be 1/2 times mass times velocity final squared and minus 1/2 times mass times velocity initial squared. Awesome. So this is the work done by all the forces acting on the body. Since what is the meaning of work? We can contribute energy to something simply by doing the work. That means the work can help us to transfer the energy from somewhere else to your object. And that energy difference is now 1/2 mv squared and times some other 1/2 mv squared. And that means this is the energy transferred from somewhere else by the process of doing the work. Okay, please remember, the F may not be a single force. The F may not be a single force. There might be multiple forces like F1, F2, and F3 acting on a single body, and it's going to accelerate, and along the path, and then we're starting from some kind of initial velocity to a final velocity. So the net force means it's the sum of all the forces, like the F1 plus F2 and plus F3. So this is all called the net force. Is it okay for you? And Newton's second law told us that the net force is equal to the mass times the acceleration. So the F dot dx means the really small amount of work, like you are now moving with a really small amount of displacement, and the really small amount of work is the F times the dx. Okay, the F times dx, really small small amount of work, and I'm going to integrate all these terms. And that means this is all the work you can ever done to your object. And the work done to the body is now equal to all these terms. And this means the energy transferred maybe from a body or maybe from somewhere else to this object with mass m. And it turns out to be this kind of energy is the gap between two states, the initial state and the final state, and that means the energy gap. Since this kind of energy is so important, so we must give it a really special name, which is the kinetic energy. Which is where the kinetic energy is 1/2 mv squared comes from. 这样可以理解这个动能是怎么来的吗？以前也许高一的时候我们会用这个 F 等于 ma， 这也是一个快速的做法。But however, the F, what you're thinking right now, is a uniform force, it's a constant force, and your body is now moving with a constant acceleration. It's uniform accelerated motion, but now you have a stronger tools. You can apply the calculus to calculate the net work. 更严谨的方法，你会发现这个物体所做的能量，它造成的能量差，在这个初跟末 initial state and final state， 就是来自于我们所定义这两个动能的差别。Okay, so I can write it down as the net work done by all the forces is equal to the change in kinetic energy. The change in kinetic energy. 这边有趣的地方是啊，通常我们要讲什么物理量的改变，都会用 in 这个介系词，比方说 change of velocity、change in position， 或者说这个 change in pressure、change in momentum， 我们都会用 in 这个介系词啊。So the net work is equal to the change in kinetic energy, which is the kinetic energy, the work energy theory. In fact, this is not the first time you hear the work energy theory in Chinese. Can you guess the Chinese name for the work energy theory? Does anybody know its name in Chinese? Louder. 功能原理，没错. This is work energy theory. And to be more specific, what kind of work? Net work. The work done by all the forces, this is the net work. What kind of energy? Potential energy? Or heat energy? No. What kind of energy? What kind of energy should it be? King what? Kinetic energy. 这应该是什么呢？动能，没错 ，kinetic energy. So all the work, all the forces acting on the body, the work done by all the forces is equal to the change in kinetic energy. So you can imagine the change in kinetic energy is some kind of energy gap between the first initial state and the final state. This is the work energy theory, or to be more specific, net work kinetic energy theory. OK， 所以啊，今天呢，大家就可以利用你学过的基本工具来了解到为何动能前面呢是1/2，而不是说 it should be 1/3 mv cubed or even 1/4 mv to the 4th power. OK， 这样大家就知道啦。OK, are you ready to level up the kinetic energy? So far, does anyone have any question? You are welcome to ask me. Yes.
I want to ask, since in the first equation you wrote,
yes.
You assume that the force and displacement is in the same direction.
Yes.
But in fact, they can be at different directions. Then how do you prove that it is the conclusion is the same?
Oh, no problem. Actually, you can do this in 2 dimensions. If it is in 2 dimensions, you will get a final velocity. Maybe the final velocity is now pointing to the x. And for some other forces pointing to the right will cause the velocity change in y direction. So I'm going to compose the 2 velocity in 2 different directions, and I've used the Pythagoras theorem to sum them up. So because I just want to make things more simpler, so I want to calculate 1 dimension. In fact, you can do this in 2 dimensions, but however, you would have 2 components of velocity, like velocity in the x direction and velocity in the y direction. But that won't make any change. You will still obtain the result that the change in kinetic energy is still equal to the sum of all the forces, the work done by all the forces. Can you accept it? Okay. For the next step, I'm going to level up. I want to teach you something related to special relativity. Does anyone know what it is? 什么东西？特殊什么？还是相对论，或者狭义相对论 （special relativity）。And please don't worry， 你不用听到相对论就觉得好像很可怕。事实上，在我高中的时候啊，相对论是被放进教材的。当时除了光电效应以外，还有另外一个叫做 counter scattering effect， 叫做康普森效应。那光电效应是光子下去，然后呢电子跑出来，光子不见了。那康普森效应是用那个 gamma ray 很强的能量光子，光子下去，电子是出来的，但是还有一个变弱的光子也跑出来。那在当时来看是觉得很难以理解的，因为当时的古典物理科认为你光下去被散射出来，波长频率应该是不会变的，但是我们实验结果发现它变了。于是呢，我们就利用光子跟电子之间的碰撞，去探讨那个波长的改变量。那也就是这个被高能光子撞到的那个电子它动得特别快。And when something is now moving really fast, and Einstein's special relativity told you that the mass is going to be correct. You should change the mass. You should change the mass. When your mass is at stationary state, stationary state 是什么意思？就是静止的意思。If it is at stationary state, the mass I write it down and put a sub not. 这个 ND 就代表它的静止时候的质量。And Einstein say, when it's now moving really fast, actually the mass is a function of velocity. And the function is the vast mass divided by the square root of 1 minus v squared over c squared. This is what special relativity told us. But usually, if you're moving slow, so let me remind you, the speed of light, what is speed of light? 什么数？光速。The speed of light is 3 times 10 to the 8 power meters per second. This is so fast. So usually, if you're running fast, you think you can run so fast, but compared with the size of the speed of light, you are so small. And which means the v squared divided by the c squared is something that can be ignored. If you can ignore 忽略掉这一项的话，那这个 m0 除上根号这一坨，其实就跟原本的静止的质量，静止时候的质量，我们把它称作叫 vast mass， 其实长得是相同的。所以大部分的时候，我们都不需要考虑 special relativity 是怎么去修正这个质量的。但如果你现在动的，比方说有这个 half the speed of light。or 0.9 speed of light. You're so close to the speed of light. 也就是说，你现在这个速度 v 上升了 ，too large and to be abandoned， 不能够抛弃它的话，那我们就要去修正这个质量。Which means if you want all the physics quantity that has the mass in it should be correct, right?任何一个物理量，如果里面有包含 m 的话，那你就要去做修正。我在高中时代呢，最喜欢的第一个就是这个 momentum 的修正。 The relativistic momentum is, I'll write it down as put a stop, that means relativity. 这个叫相对论性的动量 relativistic momentum is equal to the mass times the velocity, right? But for classical situation, you should only put the mass on this term. But if your object is not moving so fast, then you should replace the rest mass simply by the enhanced mass. What should I say? It will be enhanced. Think about it. If your v is now 0.9 speed of light, 0.9 speed of light, and something under the square root is going to be less than 1. If the denominator is less than 1, then the whole term is going to increase. And that means for a moving object, its mass is going to enhance. 一个东西一旦动起来，它的质量会比你原本静止时候来的大。所以如果你想要修正这个相对论性的动量啊，你就可以把这个 mass as a function of time 摆进去。那现在你就要用相对论性去修正它。And one more thing, since the square root of 1 minus b squared over c squared is so complicated, so sometimes, most of the times, the scientists prefer to write it down as gamma times the rest mass. The rest mass, and the gamma means the 1 over the square root term, okay? In order to simplify this. So, if I want to find out the relativistic momentum, and that will be the gamma times the m naught. Now, 目前来讲，这个就是我们的 relativistic mass 已经考虑相对论去做修正，以及膨胀质量 and times the velocity. And let me tell you something. This is correct. 这是正确的。那我在高中的时候啊，曾经试着想要去证明我刚才所讲的康顿散射的这个公式。那因为被高能光子撞出来的电子啊 ，move so fast， 动得太快了。那我们的那个章节就丢了这个相对论的质量修正给我们，然后我自然而然的我就会想要去修正我的动能，比方说 relativistic relativistic kinetic energy 相对论性的动能。I would think this is 1/2 times the gamma times m naught, which is the relativistic mass. 我已经把这个修正后的质量给它带进去 and times v squared. And I thought it was right. But it turns out to be, I was wrong. If I want to find out the relativistic kinetic energy, I cannot just simply replace the rest mass by the enhanced relativistic mass. I'm so confused. So that's why no matter how hard I try, I still cannot go to the final equation I ever wanted. This is wrong. And you might be wondering, what happened? But don't worry, since that is why I should first teach you what is the physics meaning for work. And work means the change in kinetic energy. And the energy, some kind of gap between the initial state and the final state. 你可以把动能想成是the energy at stationary state 静止状态跟运动状态这两个之间的能量差。So based on this concept, 我们的相对论性的动能其实更适合的应该用什么来表示啊？ You should write it down as the total energy minus the rest mass energy. The rest mass energy. You might be wondering, what is rest mass energy? Okay, 我相信大部分人应该都听过一个很 famous equation, and that is the energy equals m what? mc? Yeah, mc squared. Yes, m naught c squared. The rest mass energy 你可以理解它是静止时候的能量，叫静止质能。 And you might be wondering, what is rest mass energy? Your object doesn't move at all right now. It is at a stationary state. How supposedly it should have some kind of energy? You can imagine this energy is some kind of energy to assemble all the elements, all the molecules, all the atoms into a single mass. That is the energy you require to assemble the mass. 你可以把这个静止能想成是你要把质量组成所需要的能量。The energy you require to assemble the mass. But if you're not moving, this is the energy at stationary state. But when your object is not moving, 它开始动了，那你的质量就会怎么样？就会膨胀。所以这个 total energy, let's say the total, or you can prefer other name. Other name is relativistic energy. 这个叫相对论性的总能也就是你拿这个膨胀后修正过的质量 the enhanced mass times c squared. And the mass is the gamma times m naught. 目前可以接受吗？ The relativistic kinetic energy should be the gap, should be the total energy gap between the stationary state and the moving state. If you can accept this, then we can move on. That is, the relativistic kinetic energy is now equal to gamma times m naught c squared. This is the total energy minus the rest mass energy. And since there are gap in m naught times c squared, I can take it out. I can take them out as m naught c squared and times the gamma minus 1. Is everything okay right now? Okay, so this is the hardest part. The hardest part. The gamma, what is gamma? Gamma is equal to 1 divided by the square root of 1 minus b squared over c squared, which means I can write it down as all this term to the half, to the minus half. Is it okay? Is it okay? 这个根号再放在分母，根号的1/2，然后再加上一个负1，然后呢，我们可以得到现在这个 gamma 就是这一坨的东西。那如果你只是观察这一项的话，你得不到什么有趣的结论哦。But a few weeks ago, I told you how to derive the result of taking the derivative of some normal function. Do you remember that? Taking the derivative of a normal function is basically by taking the limit as delta t approaches 0. 你要去取一个这个多项式函数的微分的结果，像 t 的 n 次方微分变 n 乘 t 的 n 减 1次方，我们就是取极限。那取极限的时候，里面就会有一个这个像二项式的东西，我们要用 binomial theorem 来给展开。Okay, so I'm going to expand this term by using the binomial theorem. Binomial theorem 去展开，看看你们有没有跟上。What is binomial theorem in Chinese? 二项式定理 ，awesome， 没错，我们用二项式定理把它展开。OK， 好，这就是我目前最困难的工作。那我把等号拉在左手边一点后，它现在就变成 m naught c squared times the gamma. Okay, I'm going to expand the gamma. I'm now ready to expand the gamma by using the binomial theorem. So for the first term, the very first term is 1. No problem. And the second digit is n. The n is minus half and choose 1. I'm going to choose 1. 1 what? The minus b squared over c squared. And for the third digit, it will be n choose 2. I'll choose 2 minus b squared over c squared. So since I choose 2 of it, please don't forget 2 squared to the second power. Okay. Let me ask you one question. B squared over c squared, is it bigger than 1 or less than 1? Bigger or less? less correct。这是一个比1还要小的东西，你应该可以想象到后面3次方、4次方以后，这个小于1的东西就会变得更小。So I can fairly ignore all the digits behind. I should only focus the 3 first digits right in front. And for the rest of it, I just get rid of it. So 这边可以加个约的 ，OK 吗？现在下面这一整坨呢，就被我当作是我们这个 gamma 的展开式。All the digits expanded by from the gamma by using the binomial theorem. However, don't forget the -1 and put it down. Awesome, we are so close. We are so close. Simply by taking a look at this, I can cancel the first term and the last term, which is 1 minus 1 equals 0. So what we should really care about is the 2 digits, the n choose 1 term and the n choose 2 term, the 2 digits between. Is it okay? Okay, let's keep going. Since n choose 1, let me have you remind something. The n choose m means the n factorial divided by the n factorial times n minus. If I want to calculate the phi choose 2 is going to be 5 times 4 divided by 2 factorial. Okay, 工具有了，对不对？ Now I'm going to do the same thing to n choose 1. N choose 1 is so simple. It's so simple. It's simply n. So I can put the minus half down and times the minus b squared over c squared. Okay, 精彩的来了。好，现在要 n choose 2. So it's going to be minus half times minus half n minus 1. 你要再扣个1 because you're choosing 2, right? So 2 factorial down below and times minus b squared c squared squared. Is it okay right now? Is it okay? So the first term is going to be b squared divided by 2 times c squared. And minus half times minus half minus 1. This is minus 3 halves. 二分之三 minus 3 halves times minus half 也就是正的4分之三，对不对？那就是3 quarters divided by 2, and that means 3 divided by 8就变成8分之3了。好，所以这边要给它加上了3 times b to the 4th and 8 times c to the 4th. We're so close. Since we can cancel the c squared term, the c squared, and c squared leaves 2. And they both got b squared, so later I can take out the b squared, and they both got the 2. I can take out the 2, and that means your 8 is going to be 4. Is okay? So it is going to be 1/2 times brass mass times b squared, or what is more, times 1 plus 3b squared over 4c squared. Finally, this is the relativistic kinetic energy. As you can see, this is not equal to 1/2 times the gamma times m naught and times c squared. 就是以前初学的人都会认为，你想要去找相对论性的总和，就是把质量换成 gamma m， 换成膨胀的质，sorry, this is v， 换成膨胀后修正的质量。但是按照我们对于这个动能的理解 is the change in energy between the initial state and the final state。那我们算出来其实是这个传统的1/2 m 0乘上 v 平方。 这个东西，如果说这个是 relativistic kinetic energy， 那你也可以把这个东西啊当做是这个 classical kinetic energy， 也就是古典传统的动能 ，OK 吗？大部分不需要修正质量动能。那这个 classical kinetic energy 乘上1加上这个4c 平方分之3b 平方，就是真正的相对论性的动能。那跟你认知上，如果你只是把质量带掉的话，它就会变成 gamma 直接乘上 classical kinetic energy， 那这个等式是不成立的 ，OK 吗 ？OK， 这样各位啊，对于动能的了解，我相信呢已经有大一深的程度了。但是啊，你会发现很意外的，你好像都听得懂，对不对？没错，这个是一个你可以吸收的、可以衔接的内容。那因为这是弹性课程嘛 ，we can learn anything you want。Everything you're interested in。当然我们下周也可以带各位去户外做一些有趣的动手实作。So, any question? You're welcome to ask me any question if it's not that private. Sure, yeah.
So what is the velocity is very close to the speed of light.
And that means your mass is going to be infinite. Yes, infinite. 这相对有说啊，有那个，如果你把一个东西丢在很快速运动的太空船，那那个时间呢就会呢变得相对比较慢哦。打趣的来说，就是你如果看到太空，你看得到的话，太空船里运动的人啊，他会好像慢动作，一个原本只要花5秒钟就能做的事情，他会看起来好像要慢动作的，可能做10秒钟，类似这个样子。所以呢，如果有一天你真的可以用光速在宇宙行进的话，这个对于那个舱里头的人来讲，等于像时间静止的一样，你会用超慢的动作做刚刚的事情，那看起来就像是没有动脑。好，那也有些人就是用你问的问题也不错。If the velocity is that really close to the speed of light, and your mass is going to be infinite， 这里可以用来解释为什么有些东西啊，有些人会用这来解释，没有东西比光速还要快的。因为当你达到光速的时候，你的质量就会 infinite 超大，大到呢，其实已经没有讨论的必要，没办法再更快了。这也是一种相对论的说法。OK 吗？好，那当然，相对论再讨论下去是可以很难的，可以很复杂的。但是我们今天是 focus 在 work, energy, and some simple special relativity。OK， 那我倒是很意外，因为你们感觉都是在中考内可以听得懂，因为像高2嘛，对不对？之前我在高3教，高3就是感觉在中考内，但是我没有机会试第2节课。那我们以后有弹性课程嘛，说不定呢还可以再帮各位多补充一点课外科普的知识。这个今天对各位来讲呢，会太艰涩吗？
觉得
我觉得吗？我觉得这是我精心挑选，我觉得刚好是可以懂得高中的一些东西，再加一些呢，你就可以衔接起来。But is English or physics more harder? Which is more harder for you? English. 今天也是让你们感受一下，就是如果你以后到大学去，教授英文上会是什么味道的那以后如果有这种在比较衔接的教材，我也可以用中文教啊，对不对？你可以跟我讲说，老师，我们下周想要听什么东西，去听讲，我会的我就可以整理一下给你，我不会的我就回去读书。那当然你不要问太过分夸张的东西。老师，我要学什么量子色动力学，外加量子场论，再加上量子电动力学，搭配弦论什么东西的这个我也听不懂你应该也不知道你在讲什么。那这个我们就不一定会讨论下去那或者说我们之后学到牛顿力学，你可能会好奇说，老师，请问一下，关于这个质量关于今天这个质量呢，它也是一个 function of time， 或是 function of position。质量呢，也是一种在不同时间或是位置，它也是一个变数。 那我们在分析力的时候呢，不就比较困难了吗？这个呢，我觉得是可以衔接来讲一下的 ，OK 吗？那还有一点时间哦，那我们就先到这边休息 ，OK 吗？哦 ，If you have any questions, you're welcome to keep asking them. Okay, right in front on the stage.
要关掉，因为录节。